Two engineers, same Gemini CLI, same model, identical task. One gets a prototype, they grow away by the end of the day. The other ships to production by Thursday. The difference is not intelligence. It is not experience with AI. It is not how many YouTube tutorials they watched. It is one skill, specific, learnable, and repeatable, that most engineers have never been explicitly taught. By the end of this video, you will have a 6-element prompt architecture that transforms vague AI output into production-grade code every time. With Gemini CLI, with Claude, with any model you want to choose. Now let's build it. Here is what I watch happen when engineers pick up AI tooling for the first time. They type a sentence into Gemini CLI, the model responds, they look at the output, they type another sentence, back and forth, 15 iterations and 40 minutes into it. They end up with something that almost works. Then they tell me AI is actually slower for anything real. But the engineers who move at 10 times speed do something completely different. They spend 60 to 90 seconds writing a precise specification upfront, and they get production usable output on the second or the third attempt, not the 15th. The model does not change between iteration 1 and iteration 15. The specification does. And once you internalize that, prompting stops feeling like art and starts feeling like engineering. There is a structure to it. Let me show you exactly what that structure looks like. Every high quality prompt has 6 elements. Think of this as your prompt architecture. Element 1, outcome. What do you want to exist when this is done? Not what you want to do, what you want to have, a file, a function, a test suite. Be really concrete. Element number 2, constraints. What must be true about the solution? It could be tech stack, patterns, libraries, performance requirement, security requirements, so on and so forth. This is where most prompts fail by omission. The model fills gaps with assumptions, and in most cases, those assumptions are rarely yours. Element number 3. Scope boundary. What is explicitly out of scope? AI models drift towards completeness. They will add things you did not ask for because it seems helpful. If you do not define the fence, the model decides where the fence is. Element number 4, prior decisions. What has already been decided that this code must be consistent with? Existing architecture, established patterns. This is what separates a prompt from a specification. Element number 5, verification criteria. How will you know the output is correct? If you cannot specify how to verify, you cannot evaluate. This is both a prompt quality signal and a near miss prevention mechanism. The next is element number 6, format. How should the output be structured? Single file or multiple files? TypeScript strict mode or JS doc? Which test framework should be using? Inline comments or no comments at all? 6 elements. That is the architecture of a prompt that produces production grade output. I use this exact framework whether I'm running Gemini CLI in the terminal for fast iteration or handling a complex task of Claude for deep reasoning. The elements do not change, the model changes. The depth of each element adjusts, the architecture is going to be consistent. 2 contributions from this video. Contribution 1. Every production quality prompt has 6 elements. Outcome, constraints, scope boundary, prior decisions, verification criteria, and format. Use all 6. This is not a template. It is the architecture of clear thinking translated into AI instructions. Contribution number 2. Match the tool to the task. Use Gemini CLI for the velocity, fast iteration, terminal native, workhorse task at 0 additional cost. Use Claude for depth, complex reasoning, multi-file refactors, security-sensitive work, anything where you need the model to think out loud and surface trade-offs. The spec is the same. The tool choice is deliberate. Here is what this changes at the team level. When your team shares prompt templates, and they should be, they are sharing specification knowledge. They are encoding decisions about quality, patterns, and constraints into reusable artifacts. This is the beginning of context engineering, which is the subject of the next video, and it is where this framework gets genuinely powerful at scale. In the next video, I'll show you why 2 engineers using identical prompts, identical tools get completely different output, and the one variable that controls everything. Subscribe to catch that and see you there.